Welcome to another Explainer. Today, we're going to completely transform your approach to literature reviews, moving you from passive summarizing to active, critical analysis. Look, we've all been there, right? You're staring at your screen, you've got, 50 different PDF tabs open, and you're just feeling entirely overwhelmed. You're probably wondering how on earth you're supposed to weave all this dense information together without just writing a super repetitive, boring list of what every single author did. Well, you're in the right place. We're going to break down exactly how successful researchers step past basic reading comprehension and jump into the much more valuable realm of true synthesis.
Okay, here is our roadmap for today. Number 1, escaping the summary trap. Number 2, the interrogation toolkit. And number 3, finding the gap.
Section 1, escaping the summary trap. To start, we really need to address a common pitfall that traps so many early career researchers right out of the gate. The absolute crucial point here is that a literature review is not a book report. A book report just looks backwards at what happened. But a literature review, it's a structured argument that looks forward. You're tasked with explaining not just what's already known, but exactly what is uncertain in the field, and based on that hard evidence, what future research is desperately needed. It's a massive mindset shift. You are telling the story of the broader research field, not just retelling the individual stories of 50 totally separate papers.
Let's look at a concrete example, because this brilliantly illustrates the difference between simply asking, what did they do, and critically asking, how valuable is this research? Look at the left side. Paper A developed an AI model for battery estimation. That's a summary. It's just a fact. But contrast that with the right side. While Paper A improved AI estimation accuracy, its validation was limited to laboratory conditions. By adding that critical analysis, you immediately signal exactly where the boundaries of that achievement lie. This level of insight is absolutely the foundation of all high-level academic writing.
Section 2, the interrogation toolkit. Now that we know what we're aiming for, let's equip you with the detective's framework to really interrogate your sources.
This is the 6 critical questions framework. It's basically your ultimate tool for breaking any research paper wide open. Every single time you read a source, you should be hunting for the answers to these exact 6 questions. What problem is being solved? Why did they choose this specific method? What assumptions were made? How is this different from previous studies? What are the limitations, and what do they suggest for future work? If you can answer these 6 questions, you have mastered the paper. We're going to walk through a few of the most vital ones right now.
Starting with the very first one. What problem is being solved? Let's figure out the real-world engineering challenge and why it actually matters.
Every good paper is solving something specific, but you often have to dig past the dense academic jargon to find it. Take this solar panel industry, for example. The core problem isn't just optimizing solar panels. The actual pain point is that traditional fault detection requires really expensive, unreliable manual inspection. The solution, using artificial intelligence, directly reduces those costs and improves reliability. You're always looking for who actually benefits from solving this specific problem.
Moving on, we don't just accept the methodology, we interrogate why the researchers selected it over all the other options out there.
It's never enough to just read that the researchers use deep learning. You have to ask why. What's really interesting here is how they justify the technical reasoning. They chose convolutional neural networks specifically because image-based inspection requires automatic feature extraction. Why does that matter? Because it removes the human bottleneck when processing thousands of visual feeds. Knowing exactly what this method is uniquely good at is going to be incredibly useful later when you start synthesizing multiple papers.
Next up, what assumptions were made? Every study has them, and your job is to sniff them out and question if they're actually realistic.
Researchers obviously can't test every single variable in the universe, right? So they have to assume certain conditions remain stable. For example, if a researcher builds an amazing robotic vision system in a perfectly lit laboratory, their unspoken assumption is that the training data accurately represents real-world operating conditions. But you have to step back and ask, is that realistic for a dirty, dynamic factory floor where the lighting is constantly changing? Pointing out these hidden assumptions is a massive part of elevating your review.
Then we have to look at the limitations. And remember, limitations are not researcher weaknesses. They're just the boundaries of the study.
Every single study has boundaries, and the best part, researchers will usually hand them to you on a silver platter right in their discussion or conclusion sections. Small data set sizes, high computational requirements, testing limited to a lab. Think of these bullet points as puzzle pieces. By meticulously categorizing these boundaries, you're literally collecting the clues you need to crack the case.
Section 3. The ultimate prize, finding the gap. Let's move to the final stage and see how all of this builds into your main goal.
This is the exact moment where you transition from analyzing what's been done in the past to pioneering what needs to be done next. A research gap isn't just pulled out of thin air. You can't just state, nobody has studied this topic. That kind of screams amateur research. A true gap is a specific, evidence-based direction that emerges naturally when you connect the dots between the limitations of multiple papers.
Notice what happens when we visually map this out. Looking at the studies from Zhang, Wang, and Kumar in isolation, they just have individual limitations. A small dataset here, a high computational cost there. But when we put them side by side in this matrix, boom, a massive trend appears. All of these advanced AI models are struggling with the exact same underlying issue. They're way too resource heavy. Just like that, you've synthesized the literature and found a major gap.
When you synthesize those patterns, they're almost always going to fall into one of 4 distinct gap categories. Technical gaps, where solutions require too much from our hardware. Methodological gaps, where everyone is relying on the same flawed method, like using only software simulations. Application gaps, where a tech works great in a lab, but fails in a dynamic environment. And finally, data gaps, which emerge when the field is relying on datasets that are just too small or lack diversity.
See how a weak guess transforms into something undeniable when it's backed by your structured interrogation? Listen to the left side. More research is needed in AI robotics. It's incredibly vague and shows absolutely no synthesis. But the right side, existing AI models achieve high accuracy in labs. However, further research is required to validate them in dynamic industrial environments. By directly contrasting what we know with the specific limitation we synthesized, you've created a professional, rock-solid research direction.
So, apply these 6 questions to your next stack of papers and see what critical discoveries you can uncover. By shifting your mindset from passively summarizing to actively synthesizing, you stop being just a consumer of information and you become a vital contributor to the field. Because ultimately, the most valuable thing you can bring to a body of research isn't a summary of what we already know, but a spotlight on exactly what we need to learn next. So, what unexplored gap is hiding right there on your desk, just waiting to be discovered?